Categories of computer and computer languages. In the previous grades, you learned that a computer is an electronic device and a smart machine. Like other machines, computers are also available in various sizes and types. In this chapter, you will explore different categories of computers on the basis of their size. You will also learn about types of computer languages. Categories of computers. On the basis of size, computers can be classified into four major categories: microcomputers, minicomputers, mainframes, supercomputers. Let us now learn about each category in detail. Microcomputer. Microcomputers are small in size. These computers are specifically designed to be used by one person at a time. Therefore, these computers are known as personal computers or PCs. These types of computers are generally used in homes, offices, shops, schools, and so on. The features of a microcomputer are: it uses a microprocessor as its CPU. It has a single user support. It is compact in size and less expensive. It has minimum data storage. The processing power is fair but limited when shared by many programs. Microcomputers are used in DTP, desktop publishing, graphics, teaching, entertainment, office jobs, and so on. Microcomputers are further divided into the following types. Desktop. Desktop computers are personal computers. These computers are designed to be placed on a table or a desk. A desktop computer has a CPU, mouse, keyboard, and a monitor. All these parts are connected through wires or wirelessly. These computers are generally used in banks, shops, homes, and so on. These computers cannot be carried around since they are big in size and require constant power supply. Laptop. A laptop computer is a small and lightweight digital personal computer which runs on rechargeable battery. A laptop computer has an inbuilt keyboard, mouse, and a monitor. It is portable in nature. Therefore, it is best suited for people whose profession includes a lot of traveling. Tablet. A tablet computer, also called digit computer, is smaller than a laptop computer. It does not have a physical keyboard and a mouse, but a digital keypad automatically appears on the screen whenever needed. This is a touch-sensitive device. You can operate it by touching the screen with the tips of your fingers. Tablet computers are available in different display sizes, which vary from 5-inch to 13-inch of display screen. A tablet computer usually offers less features as compared to a laptop and a desktop computer. Handheld computers. The computing devices that can easily be held in one's palm are called handheld computers. These are portable devices and can easily be carried around in a pocket. Some examples of handheld computers are smartphone. A smartphone is a combination of a mobile phone and a personal computer. It can be used to make calls, send and receive text messages, share documents, take pictures and videos, browse internet, and run various applications like a computer. Smartphones are touch-sensitive devices. Smartwatch. A smartwatch is a mobile device with a touchscreen display. It is designed to be worn on the wrist. Apart from displaying time like any other regular watch, a smartwatch helps the users track their health. Smartwatches can be connected with a smartphone, which constantly notifies the users of email, incoming calls, and so on. Some smartwatches are also capable of making telephone calls. PDA. Personal Digital Assistant (PDA) is a computer that fits in the palm of your hand. It helps you to store contact information and manage your daily routine works like appointments, schedules, and events. It has a pen-like stylus with which you can draw and write on the screen. A PDA is also known as a palm-top computer. Embedded system. An embedded system is a microprocessor-based system of hardware and software. It is specifically designed to perform a dedicated function within a larger electrical or mechanical system. Devices like a digital camera, microwave, washing machine, dishwasher, gaming console, medical equipment, traffic light controller, and so on have an embedded system. Let us learn about some devices with an embedded system in detail. Gaming console. A gaming console is an electronic device that is specially designed for playing interactive video games. This device has a display screen, game controller, joystick and buttons, and speakers. It can be connected to a television or a computer monitor. Some popular gaming consoles are PlayStation, Sony, Xbox, Microsoft, and Switch, Nintendo. Digital camera. Digital camera is one of the most common devices with an embedded system. Digital camera has a memory card to store all the captured photos and videos. Microwave. Microwave is a common household embedded computer. It is mainly used for cooking and reheating the food. ATM. An automated teller machine mainly enables you to withdraw money from your bank account from anywhere and anytime. ATM machine is always connected with the server of the bank. Whenever you withdraw money from the ATM machine, equal amount is debited from your bank account. Minicomputers. They have more processing power than the microcomputers. They can support 4 to 200 users simultaneously. They are more expensive. They support faster peripheral devices. They are used in big industries to control and monitor production processes and analyze experimental results. Applications of mini-computers include departmental systems, network servers, workgroup systems, and data processing systems. Examples: SGI, Sun, PDP 11x45, and VAX 11. Mainframe computers. They are bigger in size, have faster processing power, and greater storage area. They have a large multi-user network and input-output storage support. They are costlier and must be kept in air-conditioned rooms. They have multiple processors and can process large data at a higher speed. Applications of mainframe computers include host computers, centralized database server, and so on. They are used in large institutions like banks, insurance companies, railways, and hospitals. Examples: IBM 370, 3000 series, Burroughs B7900, and UNIVAC 1180. Supercomputers. They are the most powerful computer systems. The size of a supercomputer is nearly equal to one room and is equivalent to 4,000 computers. They have the highest precision and a very high performance. The performance of a supercomputer is measured in floating point operations per second, flops. Many supercomputers today can perform up to 1,000 billion of flops. They have a very fast memory and are the most expensive type of computers. They support multiprocessing, multiprogramming, and parallel processing. They are used for high-end computational applications like weather forecasting, artificial intelligence, quantum mechanics, oil gas exploration, molecular modeling, simulations and cryptanalysis, aerospace, automobile design, mechanics, biomedical research, rocket launching, and so on. Examples: Cray 1, Param, first supercomputer of India, Anurag, Titan, perfect software supercomputer, and Deep Blue. Computer languages. Language is a medium to express our views and feelings. To communicate with other people, it is necessary to use a common language that participants at both the ends can understand. Computer, being a device, cannot understand human language. So to communicate with a computer, we need some special language called the programming language. A programming language consists of a set of words, symbols, and codes that a computer can understand. It is used to write the computer programs. A program is a set of instructions written in a programming language. The process of writing a program is called programming. Those who write the programs are called programmers. Computer languages are classified as follows: computer languages, low-level language, machine language, assembly language, high-level language, third-generation language, fourth-generation language, natural language. Low-level language, LLL. A low-level language is a type of programming language that contains basic instructions recognized by a computer. The programs written in low-level language are not easily portable to other type of computers. Machine language and assembly language are the two examples of low-level languages. Machine language. Machine language is the only language understood by a computer. It is generally known as first-generation language, 1GL. It is also called binary language as it consists of zeros and ones. The bit 0 represents the off state and the bit 1 represents the on state. The programs written in machine language can be directly executed by the CPU since no translation is required. Assembly language. The assembly language was developed to overcome the limitations of machine language. It is also called second generation language, 2GL. It is the language which represents the frequently used commands and memory locations using mnemonics. In an assembly language, a programmer writes abbreviations such as A for addition, M for multiply, C for compare, L for load, and so on. It is also known as symbolic language because of this feature. High-level language, HLL. A high-level language is a programming language that enables a programmer to write programs that are machine-independent. They are called high-level language because they are closer to human language as compared to the machine language. The main advantages of high-level language over low-level language are that they are easier to read, write, and maintain. The high-level languages are categorized into the following three types. Third-generation languages, 3GLs. In 3GL, a programmer writes a series of English-like words that tell the computer what to accomplish and how to do it. Many third-generation languages also use arithmetic operators such as asterisk for multiplication and plus for addition. Some early procedural 3GLs are BASIC, Pascal, C, and Fortran. Some other advanced object-oriented 3GL are C++, Java, and C#. Fourth-generation languages, 4GLs. The fourth-generation languages also use English-like statements. They specify what the programs should accomplish without explaining how. A 4GL is fast and requires lesser time and effort on the part of the programmer. In fact, 4GLs are so easy to use that the programmers with a little programming background can develop the programs. Examples of 4GLs are SQL, Perl, Python, and so on. Natural languages, 5GLs. These languages are used mainly in artificial intelligence, AI, and artificial neural networks. Examples of 5GLs are Mercury, Prolog, and OPS5. Advantages of high-level languages. High-level language is user-friendly. High-level language requires less time to write a program. High-level language is easier to maintain. High-level language is similar to English language with vocabulary of words and symbols. High-level language is problem-oriented rather than machine-based. The programs developed in high-level languages are machine-independent, that means they can run on any computer. Programs written in a high-level language can be translated into machine language. Therefore, these programs can run on any computer with an appropriate translator. Disadvantages of high-level languages. A high-level language has to be translated into the machine language by a translator. Thus, it consumes a lot of computing time. The object code generated by a translator might be inefficient as compared to an equivalent assembly language program. Language translator. Students, you know that a computer understands only the machine language, the language of zeros and ones. That is why it becomes necessary to convert all the programs written in assembly and high-level languages into the machine language, so that a computer can understand the instructions and give the desired output. To translate any high-level language program to the machine language, a language translator is required. This software is also known as a language processor. There are three different types of language translators. Assembler. An assembler is a translator program that converts the assembly language instructions into machine codes that is zeros and ones, so that the computer can understand it. Interpreter. An interpreter is a translator program that converts the high-level language into machine codes, instruction by instruction, and also executes it after conversion. Like firstly, it will convert first instruction of a program, execute it, and then second instruction and so on. If there is any error in any of the instructions, then the process interpretation and execution will stop and will prompt for the error. The process will not proceed further until the errors are rectified by the programmer. BASIC and Fortran are the examples of such languages where interpreters are used. Compiler. A compiler translates the whole program at once. That means it generates the object code for the program along with the list of errors. The execution speed of a compiler is faster as compared to an interpreter.